2019 projectile motion. Welcome to the hockey match. Nicole is playing for her school hockey team. During the game, she passes the ball to a teammate, Josie, who is some distance away. To do this, she has to raise the ball high enough to give it flight and low enough to keep it safe. She hits the ball with a velocity of 22 meters per second at an angle of 30 degrees. A. Show us the initial vertical velocity of the ball is 11 meters per second. I'm going to redraw the diagram down here. So we have a resultant initial velocity of 22 meters per second. This is the combination of a horizontal velocity and a vertical velocity. So we need to figure out the vertical component of this resultant velocity. How do we do that? Well, this is a simple trigonometry question. And the way we attack these is by first labeling our triangle. We know that this is the hypotenuse, opposite this 30-degree angle is the opposite, and down here we've got our adjacent. We're trying to find the opposite, which is essentially our initial vertical velocity. And we've been given a hypotenuse value over here. So the things we are going to use, the variables we're going to use is O and H, which is SO, which is our sine function. Let's figure this out. The equation for this is sine theta equals O over H. Substituting everything in, we've got sine 30 equals opposite over adjacent, our hypotenuse, my bad, which is 22. To get the opposite all on its own, we need to get rid of the 22 by timesing it by itself. That means we have to times it on this side. Opposite equals 22 times sine 30. Plug that into your calculator, and what you should get is 11 meters per second. It's really important to show your working, especially when you're already given the answer, okay? You just have to prove that you know how to work it out. So make sure to be clear. So that's that. Moving on to the next question, we have B. Describe and explain the motion of the ball. You should refer to any forces acting on it as it moves through the air. You may include a diagram to support your explanation. So in terms of the motion, we know that this motion over here, this projectile motion, is split up into two components, okay? Those two components are going to be our horizontal components, okay? Our horizontal components and also our vertical components. These are vectors, so they show a size and direction, and we need to explain what is happening to each component. So the horizontal component is constant throughout the flight, okay? This is because gravity doesn't act in this component. It doesn't act or influence the horizontal velocity. Gravity only influences the vertical velocity. As the ball is going up, gravity is working against this motion, this velocity, and pulling the ball down, which is why at the topmost point we reach equilibrium. There is no vertical velocity at the peak of this projectile motion. As the ball goes down, we have a constant vertical velocity downwards, which is faster than what it was initially, okay? Horizontal velocity stays constant throughout each part of the flight. Acceleration due to gravity is working at all points of the flight downwards. So, if you were to write what I've just said, it would look something like this. All right, moving on to D. Josie was 44 metres away from Nicole when Nicole passed the ball to Josie in part A and B. Will the ball reach Josie before it bounces? Justify your answer using appropriate calculations. So, according to the question, Josie is right over here, okay? And she is 44 metres away from Nicole. So we want to figure out if the ball that Josie is passing is going to reach Josie, will the ball reach Josie? Oh my goodness, I have mucked up the story. So Josie is 44 metres away from Nicole. Nicole is the one passing the ball, my bad. Okay, and so we need to figure out if the ball will reach Josie before it bounces, okay? So essentially what this question is asking us is how far will this ball go? So we need to figure out the horizontal distance. How do we do that? Well, as per its routine now, we need to make a table. We've got our vertical components on this side and our horizontal components on this side. For our horizontal components, we always use this equation. This is because this equation is for constant velocity, and we know that the horizontal velocity component is always constant. So this will help us figure out our horizontal distance. To work out our horizontal distance, we need a horizontal velocity and time. So what do we have? Currently we have nothing, but here's what we can do. We can first work out our horizontal velocity. How do we do that? Well, up top over here, we've worked out our vertical velocity, okay, using trig. In the same way, we can work out our horizontal velocity over here. Okay, so if we want to work out the adjacent, which is our horizontal component, and we've got h, which is 22, what do? We need to use k, which essentially is our cosine function. All right, so this is how the equation goes. It's a over h, substitute everything in. We've got 30 as the angle, adjacent, which is our horizontal velocity, is what we're trying to figure out. Our hypotenuse is 22. Now we need a all by itself, so we have to times it by itself, times this side by 22. Then we're left with a equals 22 cos 30. Plug that into your calculator, and what you should get is 19.053 meters per second. So this is our horizontal velocity. Okay, let me just highlight that so we can find it easily. All right, so now we have our horizontal velocity, which is the value that we've just worked out, 19.053. Let's figure out our time component, okay? How do we figure out our time component? Well, remember, time is the linking factor between our vertical and horizontal. The time taken for the ball to go up and down will be the same as the time taken for the ball to go straight across. So how do we work time out? We will need to use some kinematic equations. So time is what we're trying to figure out in the vertical plane. Then we can drag it across and use it in our equation over here. So what else do we have? What other information do we have to work out time? We need to look at our vertical values that we've been given. Well, we've just worked out in part A that the initial vertical velocity, VI, is 11 meters per second. What else do we know? Well, we know that if we are working out the time to the top, okay, if this was VI, up top, VF is our final destination. Then we can times it by 2 later, okay? But for now, let's split this projectile motion in half, okay? So let's first figure out the time taken to get to this point here. So this will be VF, and at the top, the velocity comes to a stop for the vertical plane anyway. So VF is 0. Acceleration due to gravity is 9.8 meters per second. And what else do we have? That's about it, really. Now what we have to do is figure out time taken to the top, and then later we'll times by 2, because this is a symmetrical projectile motion. We can times this by 2. So time taken to the top, that's our mission at the moment. What's the most appropriate kinematics equation to use? Have a think, have a look at your resource sheet. I'm going to use VF equals VI plus AT. Before we go ahead and start plugging in our numbers, what we need to do is define our positive and negative, what do we call them? I always forget. Vectors. Oh my gosh. Vectors. Okay, brain blank. Anyways, so we need to assign our positive and negative vectors. So velocity is a vector. So our initial velocity, okay, as the ball goes up, okay, this is my projectile motion, as the ball goes from down here to up here, the initial velocity is upwards, okay, VI is upwards. So this is going to be my positive vector. I always make velocity positive, okay, that's just my suggestion. And it's going to be my reference vector. VF is 0, so we can't draw a vector for that. But acceleration is also a vector, and it's acting downwards. In reference to VI, okay, it's opposing its motion. It's opposing its direction. So I will have to make gravity, aka acceleration, due to gravity, a negative value. All right, so in my equation, I will have to make sure my acceleration value is negative 9.8. Let's go ahead now and plug everything in. So VF is 0, VI is positive 11 meters per second plus negative 9.8 meters per second times time. Here's what I can do. So I am going to use my onion analogy. If time is the core of the onion that we're trying to figure out and get to, we need to peel each layer one by one, okay? And so to get to time, we need to remove the outside layers first before we get to time and isolate it, all right? So the first layer I'm going to peel back is this plus 11. So to get rid of plus 11, I'm minus 11 on this side. That means I have to minus 11 from this side. So 0 minus 11 is minus 11. And then what I'm left with is negative 9.8 times time. To get rid of the next layer of the onion, our purple layer, currently we see that negative 9.8 is being multiplied by time. So to get rid of this multiply, we need to divide this whole side by negative 9.8. That means we have to divide this side by negative 9.8. So what we're left with is t equals negative 11 divided by negative 9.8. And our time to the top, according to these calculations, is 1.12 seconds. But remember, this is the half time. This is the time to get to the top. We need to figure out the total time to get to the top and to the bottom. So because this is a symmetrical projectile motion, we could times this, the time taken to get to the top, by 2, and we double it to find the total time. So total time is going to be 1.12 times 2, which is going to be 2.24 seconds. Okay, so this is the total time. Let me just highlight that. So now what we can do is we can take this time value and plug it in to this equation over here. Okay, so now we have more information to work out the horizontal distance. So let's continue this equation. We know that our total time is 2.24. And to rearrange to get d all by itself, we have to times this side by 2.24 to cancel it out. That means we times this side by 2.24. So d essentially equals 2.24 times 19.053. And plugging that into your calculator, you should get your answer to find out whether the ball reaches Josie before it bounces or not. 2.24 times 19.053, and we get 42.679 meters. So does the ball reach Josie? Does it reach Josie before it bounces?